In Geometry Section 9.1, we're dealing with reflections. So basically all of Chapter 9 is something called transformations, and it's when you move an object from one place to another without changing its dimensions. For example, if I look in the mirror, okay, I see the reflection of me. I don't see a thinner version of me. I don't see a darker version of me. I don't see a wider version of me. I see me, and all my measurements are the same. I'm just relocated in a different area. So we're dealing with reflections here, which is kind of like looking in a mirror. Then you'll deal with, there's other transformations. And basically what we're going to be doing is we're taking pre-image, so that's the original. So I would be the pre-image, and then I'd have my mirror, and my reflection would be the image. Okay? So just terminology that you need to know. For example, if I'm going to have a triangle, let's not use purple. If I'm going to have a triangle, okay, and this is my line of reflection, so if you think of it as my mirror, and I want to reflect it on the mirror, everything is going to be the same. So if I'm looking at a mirror, and there's a mirror here, I don't know if you can see in the video, but there's a mirror. If I'm looking at a mirror, okay, and I step back from the mirror, my image will also step further. So the distance between me and the mirror is the same distance between the mirror and my reflection, okay? So if, let's say this was 1, 2, 3 from this line, then it would be 1, 2, 3 here, okay? So let's call this A. This would be called A prime. So the image always has prime. So I know that A prime is the reflection of A. If this is B, and this is 1, 2, 3, 4, 5, then this would be 1, 2, 3, 4, 5. It would be B prime. And then if I have C, then this would be 1, 2, 3, 4, 5, 6. Then this would be 1, 2, 3, 4, 5, 6. And this would be C prime. So what I do here, and in all my transformations, I'm going to break it down to points. Okay, I'm going to break it down to points, and then I'm going to reflect each individual point, and then I'll reconnect it. So at the end, after I found A prime, B prime, and C prime, I'm going to go ahead and connect them, and if I did the measurements right, which I'm off because I'm just, again, estimating, I should have, it should be the same area. If I did the area of the pre-image and the area of the image, it would be the same. If I did the perimeter of the pre-image and the perimeter of the image, it would be the same. So everything is the same, it's just a triangle has relocated. The same thing can happen in a coordinate plane, except now it's a little bit more exact because you actually have points. And instead of counting, in just page 499, they give you a concept summary. So they give you these shortcuts to how to do it. So for example, if I have this line, let's make this line 2, 0 and 0, 2. Okay? Let's say I want to reflect this into the x-axis. This is the x-axis right here, right? So what I would do is I would then, if this is my line of reflection, why do I keep getting blue? If this is my line of reflection right here, x-axis, so that means this is my mirror. In this case, this was my mirror, but this is my mirror. So that means this distance, if I reflected this distance, since it's exactly on the point, it stays the same, so 2, 0. But this one is 1, 2, right? Because this is 0, 2, so I went up 2. So I go 2x and I go down 2. Do you see how that works? So it becomes 0, -2. And that becomes, so this is reflected off x-axis. And the shortcut to that is that if I want to reflect something off the x-axis, I can just focus on the points. It says here that I just have to make b negative, which is true. If I made -2, x stays the same, The only reason here it stays exactly the same is 0, a negative 0 is the same thing as 0. So this doesn't change at all. But other than that, if I say reflect over x-axis, instead of counting everything, you can just follow this shortcut that tells you to the y in your coordinate, you're going to make it negative. If it's the y-axis, it's the other way around. So instead of this staying the same, this is going to stay the same. So for me, you need to turn the a into negative, your x coordinate into a negative, and this is this one is a negative y coordinate, this is a negative x coordinate. The origin is basically, it's being reflected off of the 0, 0. So a reflection of a point is slightly more different because it's however much it's reflected. So if I wanted to reflect this line, and let's say this is 0, 0. Okay, so that means I'm going to reflect here, and it's going to reflect here. And then I'm going to reflect here. And so this is going to be my prime. So this is my image. So reflecting off a point is a little bit more difficult. And what the shortcut tells you to do is just to make both of them negative. If you make both of them negative, then it reflects. The last one is the y equals x line. The y equals x line is basically if you graph the equation y equals x, the slope is 1, right? And the y-intercept is 0, so this is the y equals x line. If you want to reflect off of that, all you have to do is take a and b, and you flip it. Alright? So I showed you the long way here, which makes it a little more complicated, but basically it's telling you to reflect, follow these steps to each individual point, and you should easily be able to find the image from the pre-image. Okay, we're going to do an example. So, quadrilateral A, B, C, and D has vertices, has these vertices, and this A wants you to reflect off the origin, and B wants you to reflect off the x-axis. And they want you, so on each one, okay, I'm going to graph the original. So this is 1, 1, that's A. 3, 2 is B. 4, 1 is C. And 2, negative 3, sorry, 4, negative 1. This is C, and this is D. 2, negative 3. So here is my shape, and I'm looking for the primes of that reflected off the origin. The origin again is 0, 0 right there. So I'm going to reflect. So A, if it reflects straight through, it should be somewhere here. B should be somewhere here. D should be somewhere here, and C should be somewhere here. Let's see if this is correct. Origin, if you look back on your notes, it says I have to make both negative. So my A prime should be negative 1, negative 1, right? My B prime should be negative 3, negative 2. Okay, my C prime should be negative 4, but this, because it's already a negative, becomes a positive. And then D prime is 2, but this is already a negative, so this is going to be a positive. So let's see here. A prime is negative 1, 1. This is A prime. Then it's 1, 2, 3, negative 3, 2 is B prime. So far, our prediction is correct. And then negative 4, 1, 2, 3, 4, positive 1 is C prime. And then D is 2. Sorry, positive 2. Oh, sorry, this is supposed to be negative, right? Negative 2, positive 3 is D prime. So that's supposed to be a negative because that's originally positive, so that needs to be a negative. So, okay. And you're going to be doing this on graph paper in class. If you do it on graph paper, the image should look exactly the same. All right. It's just, again, the whole thing is shifted from one side to another. This one is kind of flipped and shifted because you're reflecting through a point. You're not reflecting through a line. Okay. Let's try something a little easier, which is reflection off the x-axis. So I'm going to keep this green so we don't waste time. It's the same image, but this time it's the x-axis. And the x-axis is just telling us to change the b's, the y versions, the second one. Okay? So we're going to keep all of the same x-axis. So x coordinate, 3, 4, and 2. And all we're going to do is change that second one. So this becomes a -1. This becomes a -2. This becomes a +1 because it's opposite. And this becomes a +3. So I end up with 1, -1. This is A prime. Okay. B prime is 3, 1, 2, 3, -2 is B prime. C prime is 1, 2, 3, 4 up 1. D prime is 2 up 3. So if you actually see here, if I put my image over my pre-image, they're actually going to overlap, and that's okay. The reason why they're overlapping is because I'm reflecting off the x-axis. That's this right here. And the x-axis actually goes through my image. So that means all the ones from this side reflect off the x-axis to the opposite side. This is what happens. So D and C are up here. And AB reflects off of here, so A and B are over here. So there's that reflection that we have. So if it gets confusing, if you see that it does go on top of each other, that's fine. As long as you follow the directions correctly, you should be good. So go ahead and try example page 501, number 4 in your book, and I will see you in class.